Okay. What's that? Okay, so I'm recording that. Okay, let me briefly, first, let me ask, could you watch the recorded sessions? For each session, there's a recorded session. In fact, each part has two lecture sessions. One is this synchronous that we discuss on the detail on each subject, but then there's a recorded session that in that recorded session you can see how to build the program, the PLC and the HMI in the TIA. Could you watch that? I want to see your feedback regarding the recorded sessions. Okay, so please watch the recorded session, because the recorded session is also necessary. In this synchronous session, we don't have enough time to go through the detail on how to build the program in the TIA software. Maybe just a few points, but the details take time. There was two options. One option to have more synchronous sessions, say instead of 8 synchronous sessions, has something around 16 synchronous sessions or something around 24 hours course. But we prefer to divide that to synchronous and recorded asynchronous. But that asynchronous and the recorded is part of the lecture. Over there, I build the program in detail using TIA software in detail and explain how to do that. Please watch that. That's very important that you watch that and study how to build the program. Regarding the program, I checked the latest update with Jorge. He has already bought the software for you. He's waiting for the license key to receive the license key and then submit that to you. But meanwhile, you can download the software from the Siemens and using the a free 21 days free version of that. I will send you a short a description regarding how to download the software from the Siemens site. Because after all, the Siemens does not send say a CD or something like that for the software. They just give us the key. The software is available in their site, in the internet site of the Siemens. So download that. But meanwhile, before up to the time that the license key provided by Jorge, please use the free version of that. It is 21 days free version of that, but Jorge will send you soon. They're waiting for from the Siemens to get the license key. So please watch the recorded session and also download the software and start using that by using the free version of that, the free version license key. Okay. Any comment on the previous lectures? Any feedback, any comment, any questions?
It's again here. On the feedback, I can say it's positive.
Yep.
Because I've had to go back and review the way I've been teaching my students. This time we are teaching PLC.
Oh, very good.
And yesterday, where you are saying don't look at it as normally closed or normally open, look at it in terms of logic, I can say it really helping me to understand, although it's still confusing, but it can really help to understand logics, the hardwired, and the way you present it on a PLC. That's the positive feedback I have.
Okay, thank you for the feedback. Thank you for the feedback. Perfect. Okay, thank you. Any other question or any other feedback? Okay, so let's go to, let's have a very brief look on the lecture 3 and finalize the last part of that regarding the program, work on that, and then start lecture 4. In this lecture, we studied how to build, what is the process description, and we worked on the relation between the process description and the PLC program. And we studied that, okay, to build the PLC control system, something that most probably is available is the process description, not the hardwire control circuit. Yes, if you're going to replace an old, the control system of an old, let's say, plant, this happens from time to time, that there's an old plant with hardwire control system and you're going to replace that. In that case, we have that hardwire. But most probably we have the process description. And the process description, in fact, is based on logic and sequence control, which in fact indicates or explain, let's say, what is the control philosophy and what is the control requirement, and the sequence or the relation, interaction between different parts or between different actuators or sensors of the process. So there's a kind of sequence of, let's say, actions. Generally, the process description starts with some leading, let's say, initial introduction of the process, a general, let's say, overlook on the process, what is the process, and then in detail, one by one, itemized requirement. This is the general structure of a process description. Our duty is to read that, understand that. If there are any ambiguity on that, if there are some parts that are not clear, we should check again with the experts on the process to be sure that we understand the process control requirement, and then according to that, build the program. Build the program according to that. To build the program, we should also check the type of the switches, also the connection of the switches to the PLC, establish that connection if it is not, but if it is, if there's document are available regarding that connection, check that, and then considering what is the process requirement, or let's say control requirement, and what is the type of the switches, build the program, or let's say, according to the process description, build a draft program, and using that and considering this, the type of the switches, and analyzing that, analyzing different scenarios, decide on the detail on the program, and maybe we need to do some changes for the safety or some scenarios that may not be initially indicated in the process description, or sometimes, or let me say many times, it has already been explained, but maybe at the first, let's say, the first time that we read the process description and start to build the program, it was not that highlight to us. But when we try to check different scenarios, we noticed, okay, there are some more important, there are some situations that we should check again, and then again with the process description, maybe the answer or of our questions are on the process description, or maybe there was not any sufficient information on that, then we should check with the process experts regarding that. So our duty, let me say, is not to, let's say, create the control requirement, is to implement the control requirement. We should implement that control requirement as the PLC program. What is required is something that we should check with the process experts. Of course, it's a two-side, let's say, duty, and so it is not just, let's say, up to their decision. Maybe they ask something that is not possible, or we can also offer some, let's say, possibility on the control system to let them know, okay, we can do this and that, and if it is something that you're looking for, that yes, we can implement that. So it is a kind of interactive, but anyway, we should check with the process experts on that. Okay, then we started this automatic filling process, that there's a conveyor and a hopper here, and the process that, okay, the conveyor transfer a box under the hopper, and when it is under the hopper, how we can understand, can we understand that it is under the hopper? By this photo switch. So when the photo switch senses that there's a box here, the conveyor stops, then the hopper solenoid valve opens, and the materials drain on the or fill the box. When the box is sufficiently full, then the level switch senses that there's sufficient material on that. In that case, the valve should close, should be closed, and then the motor starts to move the box to clear the space for the new one. Here you saw the process description, just a short paragraph to explain what's that, and stepwise, one by one, what are the control requirements. Here you can see the program of that. Let's have a look to the program and the relation between this program and the process description. Okay. Here we see the motor. These are the electrical connection. Stop and normally close, start and normally open, photo sensor, level sensor, both of them are normally open. Please notice these are not connected, so both of them are normally open. It means that if there's not any box, the photo sensor is open. The photo sensor closes when it activates. It means that when there's a box in front of that. The level sensor, similarly, it is open. It's a normally open. So it is open, the switch is open if there's not sufficient material on the box. If there's sufficient material on the box, this closes, because at that case, it activates. So all the diagrams are shown in the normal state. Here is a simple start-stop with latching or with self-contact, sealing contact, that just keep the command for run and start, because operator just once push the start momentarily to start the whole process. After that, everything should be automatic. After that, everything is automatic. One by one, the boxes moves, filled, and then clear the space. So there's just one momentary command to run or stop. Okay, so this is just to indicate that, okay, this is just to implement that part. Simple start to stop with self-holding or sealing or latching. If it is in the run mode, here you see that there's a pilot light turns on. So this run variable not only used somewhere in some other parts of the program, but also is an output should be an output variable connected to that output terminal connected to a pilot light to indicate that it is in the run mode. If it is not in the run mode, here you see the standby. So this in fact implements this simple part. Energize the standby status light when the process is stopped. So this is simply implemented by this. But here is these are the let's say the actuation part. For the motor, let's look first on the motor. For the motor, the system should be in the run mode if the motor is going to be on. And okay, if there's not any box, let's say, if there's not any box in front of the photo switch, it means that there's not any box here. Okay, the motor should be on and
writing is not good. It's not
and then transfer some box to this point. So the motor should be on if there's not anything in front of the photo switch. That's good. So this is this part. Let me. Okay. So this shows that, of course, it should be in the run mode. So that's we have already spoke on that. But this means that if the photo sensor is open, so if there's not any box in front of the photo sensor, this is open. It is a normal situation. So the voltage here is 0 volt. So the logic of the photo is 0. The logic of the photo is 0. And since here we have a normally closed contact, so the logic of this is 1. And in that case, the motor turns on, of course, if it is in the run mode. So this is the reason that here we have the normally closed contact. So if there's not any box in front of the photosensor, the motor will be on. What about if there's a box over there and it is full? The box is over there. When the box is over there, let me just mention something before that. What will happen when there's a box in front of when the box reaches to this point, the photosensor senses that. So it closes. Let me use another color. So it closes when there's a box under the hopper. Then we have 24 volt here. As a result, the logic of this will be 1. And since this is a normally closed, so the logic of this will be 0. This means that the motor turns off. Okay, that's fine, because we want to stop the motor, the box, so the motor should turn off. But when the box filled and there's enough material on that, we want the motor to again start. This is the reason that you have this. There's a variable that checks whether there's enough material on the box or not using the level sensor. Okay, and if there are sufficient material on the box, this variable full is on, then the motor runs. So the motor runs either if there's not any box in front of the photosensor, or there might be a box, but it is full. So this is the reason that we have this logic at this point. Okay, but regarding, let's check what is the full? Okay, this in fact, you see that our initial expectation is that, okay, when there's enough material on the box, so it is full. Yes, that's correct. And so when there's enough material in the box, the level sensor closes, and so this becomes 24 volt, and so this becomes logic 1, and as a result this becomes 1, and then it is full. But there's one issue on that. Generally, when we install the level sensor and the photosensor senses the end of the box, let's say the outside of the box. Okay, it senses the outside of the box. If this is the box, for example, okay, The level sensor sends the edge of the box, the outside of the box. But the level sensor is somewhere inside. It should check the material inside the box. So from the position point of view, level sensor is installed somewhere over the material, and the photosensor is a little bit, let's say, in this figure, to the right. Okay. When the material this is full, the level sensor senses that, and then let's say, okay, this is the full variable. The full variable, we expect that. I mean that. What about if we had just this? We had this level, okay, and there's full. Sorry, and say that, okay, when the level sensor senses that, it is full. The problem with this simple program is that we use this full to turn on the motor and move the box. When the box is clear from the, when the box is clear from the level sensor, this full becomes 0. But the box is not yet clear from the photosensor, because the photosensor is generally a little bit, for example, a few centimeters or maybe 10 centimeters, depending on the size of the box, is more to the right. So there's not anything in front of the level sensor. And so the level sensor opens, but there are still the box in front of the photosensor, because the box is large and the level sensor is a little bit to the left. I don't know which direction you see, considering this shape. So we need to also yet check the photosensor. If the photosensor is closed, so if there's still a material in front, if there's a box is still in front of the photosensor, this full is still 1. So let's say when the box reach to the photosensor, this becomes 1 because this closes, but the level sensor that is here is still 0. This is the level sensor. Since this is 1 and this is 0, so the full is 0. So it is not full. When the level of the material reaches the maximum and the level also becomes 1, so this becomes 1 and this also becomes 1, both of them becomes 1, then the full variable turns on. Then the box moves. The motor starts and the box moves. Sometime the box reaches to this point. For example, at this point, there's not anything in front of the level sensor, so this goes 0. But the full is still on. Why? Because we have a self-holding of the full here. And so the box is still moving. When the box reaches to this point, let me use another color. When the box reaches to somewhere, for example, at this point, you see that the photosensor becomes 0. And so the full also, so at this point, the photo becomes 0 and the full also becomes 0. At this point, let me show this. At this point, the level is 0, the photo is 1, and the full is still 1. And at this point, initially, the level was 0, the photo was 0, and the full was 0. And when there's enough material on that, the level becomes 1, the photo is still 1, and the full also becomes 1. But the full remains 1 until the box is clear from the photosensor. When it is in this position, the full becomes 0. Sorry, it remains 1 until this time. So at this time, the full becomes 0. Yes, this becomes 0, but at the same time, the photo is also 0. And when the photo is 0, then this becomes 1 and the motor continues running. So the motor starts running when there's enough material at this moment. So the motor, okay, the motor starts at this point. Motor starts, okay. The motor starts running at this point. At this moment, it is still running, although there's not the level sensor doesn't sense anything. At this point, the box passes the photo sensor, so the full is 0, but at the same time, the photo is also 0 because there's not any box. The box is not in front of the photo sensor. This is 0, and because of this normally closed, this becomes 1 and the motor continues running. So the motor starts and continues running until a new box reach to the photosensor. Okay. And finally, regarding the solenoid valve must be open if, of course, we are in the run mode. Okay, we are in the run mode. Operator there's not enough material on the level sensor is 0. There's not enough material. The photosensor senses the box is over there. So if the box is under the hopper, let's say, if the box is under the hopper, there's not enough material on that, and the full is still 0. When the full becomes 1, when the full is 1, the solenoid valve turns off. There's a normally close here. So when the full is on, it closes. So this program implements this detail on this process description. It is very likely, and don't worry about that at the beginning, when we build the program, we may not notice this trick here. And it is very likely, don't worry about that if this happens. It is very likely that at the beginning, when we build the program, we just, instead of this, simply, we had, for example, this as a level sensor. And we say that, okay, if there's enough level, if the level reaches to 1, then the motor turns on. And so if there's not any box, the motor turns on and the conveyor brings a empty box, then stops. But when the level reaches to the maximum and the level sensor senses that, the motor should start. But then, and we may start with this simple program instead of having this. We may start just simply by this. Okay, if there's full, so the motor should run, and then. But when we implement that, we notice that it doesn't work. The box comes to this point. And then stop. The conveyor stops. Why? Because the level sensor doesn't sense anything, so it is 0. But the photosensor is still sensing that. So it is, this part is 0 and the motor stops. And then we analyze that and say that, okay, we need this full variable, internal variable full, or at least this variable full, to keep the command for running the motor until it clears the photosensor. So the motor starts when the level is reached to the maximum, but continues even when there's not anything on that. So these are something that it is quite let me say typical. I don't want to say mistake, but it is very likely that at the beginning we didn't notice all the parts. This is the reason that it's mentioned here. Consider different scenarios. So we should not just check the main scenario. We should check all the possible scenarios. Of course, the one that we studied here was the main part of the main scenarios, but there might be some special scenarios that might happen. What will happen, for example, what will happen if when the box is here, then somebody stop the push button, push the stop push button. What will happen then? then what will happen if we again start that? Does this program works well or not? Maybe not, and we should modify the program. Or what will happen if when the box was somewhere around here, for example, at this point, when the box was at this point, somebody pushed the stop push button. And then after a while, start that. Does this program still works? I don't know, really. I didn't analyze that myself to be sure that this works at this stage, at this scenario, but this is a possible scenario. This is something that might happen. Somebody go there for any reason, stop that. When at the time that the box was at exactly at this point, it is not in front of the level, but it is still in front of the stop. Does it work properly when we again push the stop? It means that does the motor turns on automatically and then moves? Okay, if it is, that's good. If not, we should again analyze that and go through that. So it is very important that when we read the process description and considering the schematic and circuit diagram and like that, build a program and check that from different, for different scenarios to be sure that it works well. Okay, any question? This is the program that is built here. The structure of the program is exactly this. The only difference is that this is based on the Siemens PLC program. So stop input number 1, start input number 0, the same input output that you have in the trainer. The run, I use the output. Why the output? It's because here, there's a light also should be on when it is run. Standby also the output. For the full also I use an output. Why again? Because it's supposed to be a pilot light here. It's supposed to be a pilot light also to indicate that it is full. So because of that, we need to have this to be Q. For the motor, definitely it should be output, and for the solenoid valve also it should be the output. This is the program based on this structure that we are going to have 2 physical start and stop push button with also some physical pilot lights for indicator. But if you have the HMI system, you don't need these 2 physical push buttons. You can start and stop that using the HMI. Just put some button here and then push that. Okay, so somebody goes, just push that. And here again, we don't need to use an input variable for that. We can use a memory bit for that. And as a result, these 2 inputs convert to some memory bit. For example, a memory bit 1.1 and memory bit 1.0, for example. So we don't need to have it. Similarly here, again, we don't need these pilot lights as a physical lights outside of the PLC or on the plant. And do wiring and like that, connect them to the input, to the outputs. Instead, we can change the color here. We can change the color of the solenoid valve, the color of the motor. For example, we can change this to the green when it is the motor is on. So in that case, again, we don't need these 3 to be output. They can be memory. They can be, for example, memory 1.5, memory 1.6, memory 1.7, because they do not do anything outside. They are just indicator. And these indicators, we can, if we are going to use some pilot lights for them, okay, they should be output variable. But if we use HMI and change the color of these boxes or the motor, the conveyor, just to indicate that the motor is on or off, because that pilot lights are just used to as an indicator to the operator. We don't need them because we have this HMI, and the operator can look at the HMI and according to that find out, okay, the motor is on by looking at by checking the color of that. In that case, these can also replaced by memory, but this motor must still remain as output and the solenoid valve because they do some job outside of the PLC. Definitely we need them. And also for the level sensor, we cannot replace them by any kind of simulation or any internal variable. This must be input. And the photo sensor also must be input. The photo sensor must be input. We cannot replace them. But these two can be replaced by memory if you have HMI, and these also by memory if you have HMI. The detail is given in the recorded session. So please read watch the recorded session. The detail on building this program is given there. If you have enough time at the end of this session, I open the HMI that and try to work on that a little bit regarding the building the program. But just let me, if you have any question, please ask. If not, let's go to the next session. Any question? Any comment? Okay. The next lecture number 4. In this lecture, we are going to build a program of a water tank level. In this program, or in this process, let's say, the process description is given later, but let me just explain how it is working, how it works, in fact. We have a tank that we assume that the tank has some inlet pipe. There's some inlet pipe that filled the tank. It is not indicated in the figure, but there's a pump to discharge that. So there's a pump here to discharge the water from the tank. If the level reach to this reach to this high sensor level, the pump starts. The pump starts and the water discharge from the tank, and so the level of the water decreases. But the pump remains on until the level reaches to the low sensor switch. When the level becomes lower than this position, level, then the pump turns off. And the pump turns off, but we have still water filling the tank. We don't know how much is that, and we don't have any control on that, but we know that it is there. It is there. So when the pump turns off, since we have inlet flow to the tank, so the level increases. Then the pump turns off at this point, but it does not again turn on when the level becomes more than low sensor. It turns on when the level reaches to high sensor. So at this time, the pump turns on, and at this time, the pump, at this position, the level, the pump turns off. So we should keep the command when the pump turns on at this point. When the pump turns on at this point, we should keep the command until the level reaches to the low. And when this is when it is off, we should keep that off until the level reaches to the high sensor. This is the main operation of the process. In addition to that, we have some pilot lights to indicate whether the level is lower than low sensor switch or it is higher than high sensor switch, whether the pump is running or not. Also, there are two selector switch for the on-off switch. If the switch is off, the pump cannot run. So the pump runs if it is in the on mode, and then of course for the manual, auto manual, if it is in the auto position, if it is in the auto position, the control system works as I explained. But if it is in the manual position, the pump is on all the times that the level is higher than the low sensor switch. So it is different from the first one. If the level is on, if the switch is manual, if it is in the manual, this is for the automatic. This scenario was for the automatic. If it is in the manual, if the level is lower than low, the pump is off. Otherwise, it is on. So it means that if the level try to increase, the pump starts and discharge, and so the level does not increase, and the level remain on this low sensor switch. Or if it was high, when the level, if the level of the water was like this, was at this position, and we switch that to manual, the pump automatically turns on and it discharges the tank, and so the level decreases and remain at this point. So in the manual, the pump turns on every time that the level is more than low sensor switch. There's not any keeping the command like this one. Okay, to implement this scenario, the main scenario, the automatic scenario, in fact, we need to keep the command. Keeping the command can be implemented by, we know that we have already studied this start-to-stop, that we have a momentary push button. We have two push buttons that if we momentarily push this, the motor turns on and remain on even when we release that. Or when we push the stop, the motor stops and remain a stop even when we release this until the stop. So there's two switches that one of them, momentary activation of one of them starts the motor, and activation of the other one stops the motor. This is the seal-in or self-holding or latching circuit. Okay, this is something that we need here because we want to turn on the motor at this, when the level is at this position, and turn off that when the level is at this position. So we need something like that to start to stop. This hardwire seal-in circuit can be implemented by contactors and just auxiliary contact. We have already studied that, and I'm sure that you're familiar with that. So just implement that. We also studied that, so I just review that we have this program, the PLC based seal-in circuit, but there are some special electromechanical contactor that instead of having this seal-in circuit, using this auxiliary contact, they mechanically or electromechanically implement that latch or implement that seal-in. In fact, this is just a photo. We are not going to go to the detail on mechanic of that, just the shape of that. But as a general structure, this maybe you have already worked with them. This contactor has two coils. This contactor has just one coil. It has just one coil. And the coil, there's a shaft inside the coil here, and when the coil energizes, the shaft goes up or goes down, depending on the design of that. Let's say it goes down, and so the contacts that are connected to the shaft goes up and down, and as a result, close and open. Okay, something like this. This is how the contactor works. For this latching relay, we have two coils. Not one. We have two coils. When we energize one of them, the contact closes and remain closed even if we take the electricity out of that, from that coil. It remains closed until we apply electricity on the other coil, or let's say energize the other coil. In that case, it opens. So there's two commands, one for latching and the other for unlatching. One for closing, the other for opening. There are two separate commands, but here we had just one command. If energize this, this close. If de-energize, opens. But this time we have two coils. So from electric, if you have this type of electromechanical contactor, this circuit, this on-off circuit, this on-off start-stop with self-holding circuit replaces by this circuit. We can have an on, or let's say start, and a off, or let's say stop. Each of them individually are connected to either of these coils. One of them to the latch coil, the other to the unlatch coil. But there's and the contactor of that the contact of that contactor, let's say the contact of that contactor is connected to the pilot light. So if you push this, this latch energizes, and so this turns to 1, or let's say this closes. And so the pilot light turns on. If we push this one, this energizes, and as a result, this opens, and so this goes off. So there are two. From the operator point of view, this operation is exactly equal to this one. There's no difference between them. From the operator, because operator doesn't care on what is the detail on the control system. The only thing that they need is this. Okay, a start, a stop, open, close, on, off, and the motor or the pilot light or something that turns on and off depend on that. Momentary push on this up. PLC also has this latching relays. In Siemens, instead of latch on latch, they use set. They call that set reset. It is the same. They call that set reset assignment coil instead of latch on latch. So for a variable like Q3.5, that let me remind that this output variable is connected to some bit memory in the output image, and when this bit memory becomes 1, the voltage becomes 24 volt and the pilot lights, for example, turns on. So here, this bit memory set or latch by this assignment coil, and reset, you see, this is the same. They have the same address. So both of them address the same bit. But this is the set, and this is the reset coil, or the reset set and reset assignment coil. So if you energize this, or let's say if you apply logic 1 on this Q3.5 sets, if you apply logic 1 on this, please notice, if you apply logic 1 on this, then it resets this one. Okay, so that circuit will be like this: on, off, or start and stop. This is connected to input number 1, 0, input 1, 0, and this is connected to input 1, 1. If I push this, this becomes 24 volt. When I push, this becomes 24 volt. So the logic of this becomes 1. The logic of this becomes 1. And since it is a normally open, so it's a buffer, so the logic of this is 1. And so the logic of this is 1. And so this becomes 1. What will happen when I release that? When I release that, this becomes 0 volt. So let me see. This becomes 0 volt, and so this becomes 0. This becomes 0, but although this becomes 0, but this is still 1. This remains 1. Because this coil, this assignment coil, only set that. It cannot reset that. To reset that, we need this one. Pushing this, okay. When we push this, okay, this becomes 24 volt. So the logic of this becomes 1. So the logic of this becomes 1 because it's a normally open, and so it's a buffer. The logic of this becomes 1, and as a result, this becomes 0. And so this becomes 0, and the pilot light turns off. And again, if we release that, this becomes 0 volt, 0, 0, 0, but this remains 0 yet, remains 0. So this is how that set reset or latch on latch coil assignment coil in the PLC works. We can use this set reset to implement the logic required, necessary logic for the water tank. Okay, so let's again look at that. This is the process. Here we have the process description. Okay, the process description is here. This is something that I have already explained, that in the off position, the water pump will stop if it is running and will not start if it is stopped. Manual mode, the pump will start if the water in tank is at any level except low. So when it is low, the motor is off. Otherwise, it turns on. But in the automatic mode, it turns on at high point, but turns off. It turns on at high point and turns off at low point. When the water tank reaches to when the water tank reaches to low point, the pump stops. So it starts when it reaches to, it is in the high, and it stops on that. And this can be implemented by a latch on latch program. Let's look at the program and then try to build that in the TIA. So this is the program. Any question up to this point? If you have any question up to this point before working on the detail on the program. Okay. Okay. So let's see how does this program implements that process description. First, look at the switches. We have an on-off switch that it is in the off mode when it is open. When this closes, it is in the on mode. We have an auto manual selector switch. The default, the normal state of that, by looking at this, you see that it is open. So the normal state, it's a normally open. And because of this pointer to the manual, it means that when it is in the manual, it is in normal. Please let me emphasize again that, remind that in the diagrams, the variables, or the switches are shown in their normal state. Okay, for this switch, it shows that the normal state of that is open, and in normal state, it is in the manual. This pointer shows that it is in manual. So if it is in the auto, if you switch that to the auto, this closes. So by looking at this, we know that, okay, what would be the state, the logical state, this input. Level sensor and high sensor, both of them are sensor switch, level sensor switch, and both of them are normally open. Okay, there's a trick on this. Of course, these are typical switch and the same type of switch. So they are the same type of switch. One of them in the top of the somewhere in the top of the tank, and the other somewhere in the lower position of the tank. Okay, but and both of them are the same. So it seems there's not any trick on that. Both of them are low. But the trick is here. Of course, it is not trick. There's something that we should take care of that. Both of them are normally open. Okay. It means that when if they are not activated, they are open. Okay. But the problem, the point is here. What's the meaning of not activated? The meaning of the not activated for the level sensor, it means that there's not water in front of that. Because when the water reaches to the sensor, it is activated. If there's not any water, if there's not anything, they are not activated, so they are in the normal. So if there is not any water in front of the sensor, it is open. The switch, the sensor switch, the switch of the sensor switch is open. If there's water in front of that, it is closed. But please notice, it means that if the level is lower than low, both of them, so if the level, this is the level, lower than low, I mean this point, there's not any water in front of both of them. So the low sensor and high sensor, both of them are open. Let me write P. Open, they are open. Okay, let me write completely. If there's water, if the level of the water is higher than low sensor switch, so it is more than low, but, so this is the level, but less than, I don't want to, let me write level, okay? But less than high, this is closed and this is open. And if the level is more than high, both of them are closed. Something that sometimes might be confusing is that we generally expect that, okay, if the level is less than low, this must be activated. No, this is activated when the level is more than low. When the level is lower than low, it is open and this is open. If the level is in between, this closes and this opens because the water like this, like in this shape, that the water is in front of this sensor, so it is closed, but the water has not yet reached to this, it is open. When the water is here, then we are in this state, that both of them are closed. And we should take care of that in the program. We should take care of that in the program. Okay, so let's have a look to the program. First, here, let's start from this point. This on-off switch shows that regardless of the level of the sensor, regardless of whether it is in the manual or automatic, how much water is on that, if the switch is in off mode, it means that if this is open, the voltage here is 0 volt, and so the logic of this is 0. The logic of this is 0. And so the logic of this is 0, and so the motor is off. So regardless on the level of the water, whether it is in the auto or manual, if the switch is off, the motor is off. And it is something that you expect. This is something that you expect. The water pump will stop if it is running and will not start if it is stopping. So regardless of whether there's water on that or not, it is in fact off. So this is because of that. So let me just move this part. Next part is on the auto manual. If this is in the manual, the motor should be, and of course, let's assume that from now on, we assume that from now on, we assume that the on-off switch is in the on mode. It is in the on mode. Because if it is off mode, the motor is off forever. If it is in on mode, then let's look at the manual, auto manual. If it is in the manual mode, then this is open. And so here we have 0 volt. In that case, the pump should turn on if the level is higher than low. If the level is lower than low, it should stop. If the level is higher than low, it turns on. It turns on. So this is something that you see here in this part. If the auto manual is in the manual mode, this is 0 volt. And so the logic of this is 0. This is a normally closed, so the logic of this is 1. This is an inverter. The logic of this is 1. And this also is 1 because we assume that it is 1 forever. It is in the on mode, so it is 1. So everything depends on the low sensor switch. When it is in the manual mode, everything depends on the low sensor switch. If the level is less than low sensor switch, let me remind, if the level, this is low sensor switch. If the level is less than low sensor switch, there's not anything in front of that. And so it is in its normal state. In its normal state, it is open. And so this is 0 volt. And so this is 0. And so the motor is off. But if the level is higher than low sensor switch, regardless that whether it reached to the high or not, the level is higher than low sensor switch. In that case, this is closed. It is activated, so it is closed. So this is 24 volt. And so this is 1, and this is 1, and so the motor turns on. So you see that this part, this line, this part, of course, this is just for on-off, and this part implements that manual, let's say, scenario. In the manual case, state, or let's say manual mode, in the manual mode, everything depends on the low sensor switch. If the level is less than low sensor switch, the pump is off. If it is mode, okay. This was 2 special cases, but the main mode is when we turn on the process and it is in the auto manual. It is in the auto mode. This is the main mode of operation. In that case, it is the pump turns on at high sensor and turn off at low sensor. Okay, let me clean this part again, just to. Okay. This part. Okay. So let's assume that we are in the auto mode. In the auto mode, this is in the auto mode, so this closes, and so we have 24 volts. And the logic of this auto manual would be 1. If the logic of this is 1, the logic of this becomes 0. So this branch does not do anything. This branch does not do anything. It is 0. But here you see that in that case, if it is in the 1, if this is 1, there's some more logic on that. Okay, this is the main part, let's say. This is the starting, stopping part. So if the level reaches to the high sensor, let me remind this. Where's that? Oh, yeah. If the level reaches to the high sensor, if the level reaches to this point, the high sensor switch closes, and this is the time that we want to turn on the pump. So let's connect that to a latch coil. Then this becomes 1. So if the level reaches to the high, this becomes 1, and as a result, this latches. And so this becomes 1. When this becomes 1, okay, this is 1, and we are in the auto mode. We are in the auto mode when this is in the motor mode, so the motor turns on. So when the level reaches to the high sensor switch, this latches, that latch coil latches. Maybe it would be better that I use another tag or symbol for that, but just to emphasize that it's a latch on latch coil, I use this. Then this turns on, and so this turns on and the motor turns on. What will happen if the level, okay, the pump turns on, and as a result, the tank discharges. Let's see what will happen if the level reaches to lower than high, but it is still higher than low. It becomes lower than high. This, in that case, when it reaches to this point, okay, the high sensor switch becomes 0. And so this becomes 0. So this becomes 0. Let me show like this. This becomes 0, but the latch on latch is still 1. Because this assignment coil can only latch this, not unlatch this. So it remains 1, and so this remains 1, and so the motor is still on. Let's say this is logic of this is 1, and so the motor is still on. But when the level of the tank reach to low, okay, the level of the tank and remain on until the level of the tank reach to lower than low. If it reaches to lower than low, then this becomes 0 because it's normally open. When the level is less than low sensor switch, there's not any water in front of that, so it is not activated at that point. Let's say it is not inactivated, it is not in its active state. It is inactive, or say it is in normal state. In normal state, this is 0. So it is open, and so this is 0 volt. So this becomes a 0 volt, and so since there's a normally close here, this becomes 1. And so, and since we are in the auto mode, so the unlatched coil becomes 1. The state of the unlatched coil is 1. As a result, the latch unlatch variable turns 0. Reset to 0. This should be, okay, sorry, this is based, LN should be set and reset based on Siemens. This LH is based on Allen Bradley PLCs. The set reset is something that used in the PLC, in the Siemens PLC, but it is there. So this, when this activates, the latch on latch variable becomes 0, and so this becomes 0, and as a result, the motor goes to 0, this logic becomes 0, and the motor goes off. So the motor goes off when the level reach to, it becomes less than low, and turns on when the level is more than high. And then it just, until the process is on and the switch is in the auto mode, the control system works like this. Turns off at this point, turns on at this point. And this is the part that works. Okay, let's look at other parts. Any question? Any question at this point?
Can
Yeah,
I?
go ahead. Yeah, go ahead.
Is there any harm if we can start with like maybe like rank 3 to be
Okay.
rank 1, then rank 1 to be rank 2? Is there any big deal on that?
Change on the order. Yeah, that's a very good question.
The rank.
Yeah, that's a very good question. Generally, there's something that I will explain later in the complementary topics at the last session. Most cases, in most of the PLC programs, changing on the order is not important, but sometimes it is important. This is one of the cases that it is important. Okay. The question is that, of course, this physically cannot happen. Otherwise, there's a kind of fault in the system. Let me just clean this. That's a very good question. Yeah, what will happen if we change the order? Okay. Let me, instead of using this one, first explain this, your question, using this diagram. The question is this: what will happen if we studied that, okay, if I push this, this turns on, sets, and when we push this, it resets. What will happen if we push both together? both together. If you push both together, this try to set that, and this one try to reset that. What will happen? The order is important in this case. If the program is like this, so you have set first the set, the rung number 1, for example, and rung number 2. In this case, the this is the reset that has a priority. Because at this rung, it tried to set that, but immediately after that, it reset that, so it resets. But if we change the order of them, let me assume that I change the order of them in the program. What will happen? In that case, if you push both together at the first rung, because it's a program, and the program runs line by line, or let's say rung by rung in this PLC. But it's a programming. The program is something sequentially. So at this rung, it tried to reset that, and at this rung, try to set that. It remains set. So the priority is on the last one. Okay, the last one. If both of them at the same time activates, if both set and reset at the same time activates, the priority on the last one is on the last one. Of course, in this program, because one of them are based on high sensor and the other on the low sensor, and physically they are apart, so we expect that it is not possible to activate both at the same time. Otherwise, there's a kind of fault in the sensors. Otherwise, there's a fault in the sensor. It's not possible to that both of them to be activated at the same time. So maybe in this special program, it's not that important whether we change these to rung 2 and 3, for example, or even these rung 1. Move to this to here. Even if you move this to here, nothing happened. There's not any thing. It still works. There's just maybe a very short delay on applying the command, but that short delay is in the order of say 100 milliseconds or something like that. If you move this to after this, but I can say there's not any delay. Oh, okay. Let me say there's not. Let me think. Okay. Just I want to be sure that the delay could be in the order of milliseconds, in the order of 100 milliseconds, 10 milliseconds, or something like that, if there are. But let me say, let's assume that it latches at the end. Yeah, there would be something in the order of 100 milliseconds, a delay in the order of that, but it is as a scan time. You know that the scan time or the sample time. It's in the order of, generally in the PLC programs, it is in the order of 100 milliseconds. That it is not that important for this one. But there's nothing important. It's not important whether we move this rung number 1 to after or before that. For these two, it is important if both of them are activated at the same time. For this special program, this special application, this might happen only if there's a kind of fault in the sensors. Otherwise, no, there's nothing. This will not happen at all. But for this program, yeah, maybe operator push both of them at the same time, just to see what will happen, both of them. Then it is important. It is important. And generally, this second one should be the safe mode. It should be the safe mode. For example, for the motor, generally the safe mode is to be off. For the valves, depend on the valve. Most of the valves, the safe mode is that they should be closed. But for the let's say safety valves, those valves that are used for discharging the high pressure gas from the boilers, for example, the safety mode for them is opening the valve. So they are safe when when the valve is open. So for the safety, the default or the safe mode is for those should be the valve should be open. But for example, for the water that charge the boiler, charge the boiler with water, the safe mode is to close that. So the safe mode depends on the process and the application. For most, I don't want to say for all, please notice, not for all, but for most of the applications, the safe mode of the motors is to turn off them, and the safe mode for the valves is to close them. So in that case, if you have set reset assignment latch for them, the safe mode should be the last one. Should be last. Any more questions? Okay, let me just mention here that, okay, there are some pilot lights to turn them on and off, and here you see that for the red and yellow, okay, this, what is this? Okay, this is something, I don't know if we need that. This happened, let's assume that the motor is on, okay, and then we switch that to the off mode. We switch that to the off mode, switch that to the manual mode. In that case, this becomes 1, and as a result, this unlatch that. So it stops the motor. And then, depend on the level of the sensor, maybe the motor turns on again or may not. So this is just to turn off that. This is just to turn off the motor if it is running when we switch the mode to manual. This is just because of that. I'm not sure if we need that or not, but yeah, we need that. If it is on, maybe not. I think we don't need this, because after all, if the level is more than low, then we switch to manual, the motor should on from this side. So if it is wrong, okay, let's keep that on. But anyway, this is just to, in fact, by this branch, we stop the motor, or let's say unlatch the command on the motor from that was generated from the auto scenario or auto mode, and leave everything to the manual part to decide whether to turn on or not. Leave everything to the manual control philosophy to turn on or off. It is just because of that, but most probably we don't need this. This is just a redundant. Okay, here, okay, let me again look at this. This is a program for that. This time for the auto manual, I don't use the input because I assume that we are going to use the HMI. Okay, for the auto manual. Okay, and also for the on-off sensor. For the low sensor, we need the input. Let me increase the size. Okay. Oops. Okay, for the low sensor, we need the input, definitely. For the high sensor, we need the input, definitely. For the motor, we need the output, definitely. Then, okay. Here, the pilot lights are assumed to be physical pilot lights outside. They're physical pilot lights, but we can remove them if you have HMI. If you have HMI, we don't need them because we can implement them by inside the HMI by changing the color. By changing the color, we can implement that using changing the color. Okay, let's. We don't have that much time to build the program, but let's look at the program in the TIA for this system. Of course, building this program in detail is explained in the recorded session. Please look at that. And there's one thing regarding the recorded session. Let me mention that initially, in fact, there's a kind of shift on the session numbers. Initially, when I prepared the recorded session, I assumed that this is going to be lecture 5, not lecture 4. The previous lecture was supposed to be lecture 4. And so at the beginning of the recorded sessions, I mentioned that, okay, this for this one, for example, for this session, I mentioned that, okay, this is the recorded part of session number 5. But in fact, it is the recorded session of number 4 because of the new arrangement. The file number is correct, lecture 4, recorded session, lecture 4. But at the beginning, in the narrative part, at the beginning, I mentioned that this is the recorded session for number 5. Please take care of that. In fact, there's a shift because we later changed the order of the lectures. So there's a shift on the order of the lectures, and I moved the complementary to the end. So this change, there's just this issue on the programs. Okay, so let me open that. Submitted version, it was water tank level with HMI, this. Okay, when you open if you have already built that, or if you download the program that I provided, you have these programs. This program is something that you have that, exactly this program. Download that, unzip that, and then when you, in the TIA, click on the browse, and then find the folder, for example, this folder. There are two, this HMI, okay, this, and then open this one. I build the programs based on version 14 because if we build in higher version, we cannot open them in lower version. But if you have the program in lower version, for example, version 14, you can open that still in version 15. I think the version that you're going to get is version 15. So that's fine. When you click on that and try to open, it asks you whether do you want to convert that to version 15? Say yes, just simple. So I built that on version 14 to be sure that if you have version 14 or 15 or higher level, you can open that. So click on that simply. It takes a few seconds to open that. Okay, completely. Okay, as I mentioned, the TIA portal has two views, the project view and portal view. This is the portal view of that. This is called portal view. We don't use that. Let me emphasize something again. This software is very complex, very advanced, but very complex. It has many, many options and many details that might be used for that. We are not going to use all of them. So you can do many of the parts using portal version view or project view. In this course, we only use project view. We only use project. So click on this project view. When you click that in the bottom left side, this is the project view of that. You can return to the portal view by clicking on this and again to the project view. We only use this project view. Many of the functions that we use, you can also do that in the portal view, but some other steps. But we only use this project view. Okay, when we look at here, this project tree. Okay, this is the, you see that? This is the water tank level HMI version 14. So here you see a PLC and HMI. If you have already built that, so you have the PLC, open that, then you have the details on the PLC. And if you click on the HMI, you have the detail on the HMI. Okay, let's have a look first on the PLC and then on the HMI. Under the PLC, there are many parts. You're not going to use to check all of them. Some of them are not used in this program at all, and some of them are not that important. Let's just go to the main parts. the main part, let's say, is here, program blocks. Under the program blocks, open that, and this main, OB1. We will look at this, what's the meaning of this OB1, but just click on that, double click on that. My computer is not that fast. Well, let's say it is too slow. Okay, here you can see the program. Let me just drag this down. Okay, here you can see the program. This is the program, okay, auto manual, sensor switch, low sensor switch, on off, and motor, and these, okay, up to this point. So I don't use those, I don't need to implement this part because I'm going to change the color. Instead of having pilot lights, I'm going to change the color in the HMI. In the HMI. So, but the main part of the program is this exactly the same, just using this. Okay. For the HMI, let me open the HMI part. Again, in this HMI, it has many parts. The main part and the part that we need that is this one. Open these screens. It's too low. It's too slow, I don't know. And this root screen, okay, this root screen is the root. Of course, you may have more screen in one or two. Okay, here you can see the screen. This is where where we build the screen. Any question? Okay, this is the screen. Yeah.
Its main aim
Any point?
To make the system user friendly.
In short, PLC can connect the components together.
Because the PLC itself, you'll not be seeing.
Amara, mute your mic.
Can you? Sorry. Can you see my screen?
Yes, but the software, uploaded within it.
Okay. Here, in fact, you have a switch, on-off switch. It is explained. The detail on how to implement that are explained in the recorder. Please look at that. But it comes from here. You see that there's a on-off switch here. So I can just simply drag that here, and then okay, let's increase the size. The size is this. Okay, so on-off switches. So this is something that you can bring from here. So on-off switch and auto manual switches. These are just circles that I use these circles. And then, for example, just as an example, I want to show you how we can implement that. Instead of the pilot lights, we can change the color. For example, here there are two rectangles and two circles. Increase the size a little bit. Even more. Okay. I group them. You can ungroup them by right click and then ungroup them. Okay. Here you can see, for example, this circle. This circle. Here are the properties of that, the position of that, the radius of that, the appearance, the color of that, okay? But on the animation, under the animation display, this is something that I define for that and explain. This is explain how to define that, so I'm not going to go through the detail on that. But you see that the appearance of that, under the appearance, it is connected to the motor. The motor is the variable Q0.0, I think. Yeah, it was Q0.0. Let's look at that again. Yeah, Q0.0. So in the HMI, this is connected to the motor. But what will happen? If that motor Q0.0 is 0, it means that the motor is off. The color of this circle is gray. If that variable, the motor variable is 1, it means that the motor is on, then the color of this turns to green. So if this circle is green, it means that the pump is on. If this circle is gray, it means that it is off. So it is how we can implement, we can change the color of the objects at this, the color of the objects when the motor is on or off. Or even I think for this one also, this is also this part, this pipe, the color of this is the symbol of the pipe. Okay, this is schematic of the pipe. So if it is also connected to the motor. If this is the motor is on, you see, if the motor is on, the color becomes green. If the motor is off, the color is dark gray. Or for example, here, the light of this is a photosensor. Sorry, this is the level sensor. Again, this level sensor, in fact, includes a rectangle. How to build this? Okay, it is explained in the recorder, but there are just 3 rectangles, just these rectangles. Okay, these rectangles are placed here and a line here to indicate as a wire. Okay, but the color of this center one, changes depend on the low sensor switch. Depend on it. You see, I connect this, the color of this, the color of that to the appearance of that. The appearance of that depends on the low sensor switch. If the low sensor switch is 0, it becomes red. If the low sensor switch is 1, it is yellow. Why I select this? It's because of that. If the level of the sense of the water is less than low, it's a kind of warning. We should send a warning to the operator that the level is lower than low. So I use red color for this one. If the level is lower than low, the color of this rectangle becomes red. Otherwise, it is yellow. To indicate this part, that the level is somewhere in between, okay? The level is somewhere in between, for example, and make it blue. This is something that I use. If you decrease the size. Okay, here it looks like that there's just one rectangle here, but in fact there's another rectangle here that the border, it doesn't have any border, so I can move, you see, it's a rectangle here, okay? And also there's another rectangle here. You see, there's another rectangle. It doesn't have any border, or let's say the border color is the same as that. The color of these, for example, the color of these or the color of this, let's show this one, for example. The color of these changes. Let's look at that. It is connected to the properties of that. This is this one, okay? Again, there are the position of that and like that, but I add some animation. The appearance of that is connected to the high sensor switch. If you see, if the high sensor switch is 0, the color of that is this gray, light gray, this. But if the high sensor switch becomes 1, the color of that is blue. So if the level reaches to this point, if the level reaches to the high sensor switch, this becomes blue. And so it means that something like this, something that you see is something like this. You can see that the level, all of this is blue. So it is also blue. So the operator understands, okay, the level is high by looking at the figure. But if the level is less than the high sensor switch, this is gray. And in fact, it is something that you see. In fact, there was a box here in the HMI, but we don't see that because it is gray. And we don't see that. It has the same background. The color of that is the same as the background, and so we don't see. But there's another box here, this box is connected to the low sensor switch. If the level is lower than low sensor switch, it means that the low sensor switch is 0, then the color of this is gray. You don't see that because the level is lower than low. But if the level is more than low sensor switch, if the level is more than low sensor switch, the color of this box becomes blue. And so as a result, it looks like this. It looks like this. Okay, that the level is more than low, but less than high. So this box, so in fact, there's a box here, and there's another box here. And both of them are blue. It means that the level is somewhere between low sensor and high sensor switch. This is how we build that. The detail on how to build that is given in the recorded session. So please look at that. Just I want to mention some important issues. Any question? It takes something around 1 hour to build them. So it's we record that so you have enough time later to read that. Yeah, go ahead.
Yeah, it's not a question, it's a point of information. In our country, there is a curfew that starts very early.
Oh.
So I was kindly requesting maybe if we can summarize. We are enjoying the presentation. It's okay, we are learning, but just to inform you, there's a curfew that is limiting some of us. We go for.
Yeah, it is possible. If you prefer, we can have tomorrow and the day after tomorrow sessions. We can, you see that we have 4 more synchronous session, and the rest is recorded. You can download the recorded, all the recorded except number 5. For number 5, as I mentioned, it was ready, but I noticed that the voice is not good. It's very noisy. So I'm going to repeat that. I'm going to go to college in this Friday and repeat that. So in that case, yes, it's possible. If you're ready, we can have all the 4 sessions that remain tomorrow and the day after tomorrow. Or you let me know. Is it good? So it would be 4 sessions. Something around 6 hours, or we may have 2 sessions tomorrow and the day after tomorrow, and then I don't know, maybe later in Saturday or on Monday morning or on Monday. But if there's possibility that there would be a curfew at the end of this week, so it would be better maybe that we have those 4 remaining sessions, all of them in these 2 or 3 days. Thursday, Friday, and at most Saturday, and then you have, if there's anything happen, you have all the recorded sessions and you can continue. What about this?
Can I speak on my behalf?
Yeah, go ahead. Yeah.
Okay, for Sigalagala, tomorrow, Thursday and Friday, students are defending their thesis projects.
Okay.
So it may be a challenge.
Okay.
And so for Sigalagala, I can say that's the challenge for tomorrow and Friday. Okay.
So when is good for you? What's your suggestion regarding that? On Saturday or
up to next week?
Next week.
Up to next week, yeah, because we're expecting to start some exams. When exam starts, we won't be that busy, so maybe up to next week.
You see, my time is like this. Next week, this week I'm free. Next week, I can Monday morning from my side. I mean that afternoon, Monday afternoon for you. Until I can say, if you start at 4 o'clock until 6 o'clock, you can start earlier on Monday. On Tuesday, I can. Okay, of course, Tuesday is I don't know. It's up to you. Monday afternoon for your in your side. Tuesday afternoon and Wednesday afternoon in your in Kenya, or morning in the Canada, I can finish all the lectures if it works for you. If you
I concur with that.
What about others? What's your suggestion?
I also think next week is okay. We can go with what you've suggested.
So what about this? Have an extra session on Monday morning, just one session, and then Tuesday and then Wednesday. And then next week, we decide if it is necessary, we can have extra session at Tuesday or Wednesday to finish that, because we need 4 more synchronous session, one on Monday, the other at Tuesday and Wednesday. So the one remain that one also can be handled in either Tuesday or Wednesday. Okay, so what about this? We can have an extra session, or let's say an earlier session on Monday morning at the same time. And then at that time, decide whether to finish everything next week, or we have enough time to continue for the week after that. What about this?
I agree. We can do it on we do it on Monday. Then when we finish the session, we see how the week is going.
Yeah, that's
so like for now we can plan for Monday. Then now for Monday, after the lesson, we can discuss. We see how it can go.
That's good. So I will send the announcement, an email to everybody that we will have a session on Monday. The same time is good for you at 4 o'clock, 4 p.m. Is it good for you?
Okay.
Okay. Yeah, it's okay. It's okay.
So we will have the next synchronous session on Monday at 4 p.m. And then at that time we can we have enough more information regarding what to do for the next step. That's good.
All right.
Okay, very good. Okay, so let me emphasize again, please watch the recorded sessions. Many details are given over there. We don't have that much time to go through all the details, especially on building the program. The details on how to build the program, both PLC and HMI, and detail on how to work with the TIA software is given in the recorded session. So please watch that, and also download the PLC software. I will send a detail regarding how to download and which files to download from the Siemens website to download the program, and you can start using the free version until you get the license key. But the license key might be even available today, or we expect that it should be available. It should be reached. We have not yet, but most probably very soon. So start using the free version until we provide the main key, the license key. Okay. See you on Monday.
Okay, bye-bye.
Okay, bye. Bye-bye.